A warm good morning to and all. So this is session 2, the continuation what we discussed in session 1, the foundations of hybrid embedded systems, the specific subject, how the subject has been structured, we discussed in the last sessions. So this session we will start with that introduction part, that is the first part of the syllabus. So here in the introduction part, what are the things we will cover? First is built-in features for embedded systems as in the form of embedded target architecture, how this target architecture will be looks like. Second thing will be that how we can able to choose the different processors. So selection of processor we will discuss on the second. First we will see the architecture, second we will discuss about the selection of processors, how we can able to select a processor, and third thing is the type of dynamic memory access. So how these memory devices will be integrated, how we can able to access, all the details we are going to understand, because in the embedded system the inbuilt memory plays vital role. Always the memory access will introduce a slight delay. So how your persons will handle this memory devices effectively, he can reduce a considerable amount of delay in the system. So even a nanosecond of delay cause huge differences when you are doing in the critical operations. How I will tell you that. So when you are predicting a projectile system, a missile will be fired, you are on the defense mechanism, so you are sense the device, sense the missile. So here normally the missiles will be comes in the Mach 3 minimum, it will be Mach 3 status will come, Mach 3 speed. So you can say Mach 1 is the speed of the light. So 3 minimum, I am talking about the all minimum direction. So minimum it will be comes in the speed of Mach 3 and above. So even in that speed, even your calculative mistakes of a 0.1 nanosecond will not hit or will not block the incoming weapon, the incoming missile. So that such a precision will be required. So when we are dealing with the normal processor, when you are having a laptop or desktop, whatever you are dealing with, so even a milliseconds delay also will not impact much. The millisecond delay, even a second delay also will not impact much. So when you are going for the system in the real time, so even the nanoseconds, in the 0.1 nanoseconds what I said earlier, even that 0.1 nanoseconds also impact huge. So that is the reasons we have to understand how these memory units will be integrated, how we can effectively handle these memory devices. This is the only place or major place where the system will face the delay. Second thing related to again the memory management. So in certain cases we will go with a different type of memories. Flash memory will enrich, sometime we can enrich volatile memories. So if embedded system come across multiple memory systems, how we can able to interact with these kind of memory systems, all the things details will be discussed under the memory managements, how we can able to manage different kind of memories. So we all those things we are going to see only the fundamentals, some basics. So related experiments we have. So the parallelly we are having some practical sessions. So in the practical session each topic I have designed one programs. So each topic through the program you can validate. So whatever learning in the theoretical classes you can validate on the practical session. It will give you a great idea. So if you are going to the further, same thing again you can see memory mapping, cache replacement policies, all those things again related to the memory management. So here memory management will be given the huge impact. So the reason I said it plays a vital role, this is the place where the delay is possible, the maximum delay introduced by this memory access in any processor based system. And after that memory management we are going to discuss about the timers and counting devices. So timers, what is the role of the timer, what are the different name, the same timer, how it has been deployed in different names in different places within the embedded hardware. So all those things we are going to discuss, the name of timers, counting devices, watchdog timer, real time clock, all those things will be we are going to discuss about further end of the introduction. Then we can go in for the software development tools. So here we are learning about the hardware. Already I said in the second part we are discussing about the software. So I am introducing some of the basics concept here itself in the part 1. The reason is when you are learning certain things, your related versions, if you are learning that specific versions which need to be learned along with that hardware, that we should learn. For that purpose, when you are talking about the processor, target architecture, memory management, we should know at least some basic knowledge about how we can able to transfer the data into the system. So for that purpose, I kept some of the very basic software development tools, IDV, assemblers, compilers, linkers, simulators, debuggers. So all those things, how it will be happen, we are going to discuss further. And finally, we are going to see some of the in-circuit simulators and hardware debugging. We are ending with that first part chapter 1. So in that continuation, we are going to see some of the safety standards will be introduced over for the embedded system. So that is the overall idea about today's view. So we will discuss about our direct concept. So this is the first topic, introduction to hybrid embedded system. So you want to understand the embedded system first, some of the basic things you should know. So these are the questions you have to ask yourself. So since this subject is designed for engineers in the third year of study, so it will be understood we are introduced some of the basic concept related to the hardware already. For example, we are taught about the 8086 and 8085 microprocessor and 8051 microcontroller and ARM processor and PIC controller. So these things already you guys might have been studied in the earlier classes. So that is the reason we are not discussing much about the basics hardware components. We directly going to the hybrid embedded systems. So you have to ask yourself some of the basics question. You should have the answer, then only we are going for further you will get understand. So you have to answer that what is embedded system. Before that, what is mean by system? Everyone should answer what is mean by system. Then you should understand what is mean by embedded system. And you have to come for third, what is mean by hybrid system. So when you are answering this, what is embedded system, what is hybrid system, then you get an answer for what is the meaning of hybrid embedded system. So we will come to the first question, what do you mean by system? So everyone knows that a set of things working together as a part of mechanism or interconnecting a network or a part of a complex system. That means a complex methodology will be split into many mechanisms, we can call it as a system. So here the simple word is a set of things working together. Common layman word we can say anybody, any system, any things working together to form a single function, you can call it as a system. Understood? So in modern technology we can say that our human society and physical and biological sciences includes biological system of a human body, socio-economical system of a business organization, the technological system of an oil refinery system and physical system of a sun and its planet. Everything we can call it as a system. So everything, so any different verticals or different parts working together towards a common goal, we can call it as a system. So what do you mean by embedded system then? So we know that what is mean system. What do you mean by embedded system? So here you come in more technical. So any system which forms a part of your computing activities. So embedded systems we can say a general purpose computing systems. So if you are taking a computing system for a specific operations, it will run on that, we can call it as technically a embedded system. For example, you are having a microwave oven in your home, there is a small processor will be there. In that processor will control few functions, fixed functions in that. For example, changing the menu, timers, automatic on and off, these things will be there, it will be called as a embedded system. So when you can see wherever a touch screen you are realizing, a touch screen, a digital display, the default, the system is called as a embedded system. There is a computing device, a processing device inside the system. So commonly these are the very basic level of embedded system. If I technically take a real-time embedded system with the minimum basic needs, we can say in the central heating system, in engine management system of any vehicles, domestic appliances, so digital watches, electronic calculators, all these things are contributing for the embedded system. So we have much more example for the embedded system. We can say GPS tracking system, your fitness trackers. So here all will be some of the example for the embedded system. Why we have to know about the embedded system? The reason is the embedded system have many more advantages over general purpose computing devices. That is the reason everyone should know the importance of the embedded system. So as engineers, what we have, we are the inventors. When you as a software engineers, you have some wide knowledge about the hardware, you can make n number of inventions. That is the basic idea behind the introducing the subject by the university. Now we come across to the hybrid system. What is the meaning of hybrid system? Can anyone tell me that? What is the meaning of hybrid system? We can, in the recent days, if you hear the word hybrid, what strikes in your mind? If you are the word hybrid coming to your mind, which will come to first? So in the real time era, you can say, if you see hybrid, you can say that electrical vehicles. Electrical vehicles, everyone will say electrical vehicles, one of the hybrid system. So the word hybrid, if you say the older people, when the older educated people, when you can ask what is the meaning of hybrid, they simply say it is a gene changed. What you will say? Gene changed. Anything the gene changes taken place, they will call it as a hybrid. So though when in the 70s and 80s, 1970s and 80s, when the concept of hybrid is introduced or in the peak level, so they will know that hybrid, immediately they will think of it is gene changed crop or gene changed animal or gene changed living things, like that they will come across. In the later period, now if you are coming to your mind hybrid system, immediately it will be goes for the automobile industry. Now if you are talking about a hybrid system, immediately you will go for the automobile industry, where you can see that electrical plus fossil fuel. The combination of electrical and fossil fuel, we can call it as the hybrid system in the current generation. But here in the computing, what we should know in that computing, what is the meaning of hybrid system here? What is the meaning of embedded system? So we know that earlier you can take the what is the processor based system, embedded system, you can say embedded system. See here everyone knows that there is a processor based system, no inbuilt memory. Here there is a inbuilt memory. The first things will comes to the mind for any engineers, difference between the processor based system and the embedded based system. The first thing is there is no inbuilt memory in the processor based system, there is a inbuilt memory in the embedded system. It is a general purpose. Second thing they will say general purpose, here they will say application specific. So here we have multiple tasks can be performed in the processor based system. Here only the specific task will be performed. So these are some of the basic things you come across already. What is the meaning of embedded system and general processor based system. So what is the meaning of hybrid embedded system? What is the meaning of hybrid embedded system? So normally if you are seeing the embedded system in your household, the commercials, so what are things you are seeing that? So in your home, if you are seeing the embedded systems, like you can see microwave oven and washing machines, you can say washing machines, microwave ovens. So whatever now in the recent days, fully advanced dishwashers. So everything what we can see that only specific to that particular work, the processor is programmed, it will be fixed. So you can't do anything, it will be fixed processor, it will only do the specific application. So that's the reason we can call it as a embedded processors. This is a embedded system. Now the same embedded system, when the reprogramming will be allowed, when the same embedded system reprogramming will be allowed, we can say it is do the role of embedded system as well as this is the hybrid. The concept of hybrid. The reason is the same chipset we can place in the microwave oven, the same chipset we can place for the washing machine. That is the advantage. So I am giving us a layman word to understand better what is the difference between these two.